with that in mind, we were talking about single replacement reactions on Friday, okay? Didn't get very far on that, I don't think, but we talked about, you guys remember I gave you the activity series, okay, and we talked about, yeah, the big guy kicking the sand on the little guy at the beach. Yeah, you're going to need that probably for the rest of today. Okay, so, yeah, I'll get you one. But basically, the idea is certain metals, some metals are stronger than other metals, and they're able to replace a metal out of a compound. Okay, now remember, metals only replace metals, non-metals only replace non-metals. Okay, so let's see how far we got on this thing. I don't think we got very far. Question number 2 here, I don't think we've talked about this yet, but which sets of reactions typically involve ions in solution? In other words, the ones that are aqueous, because that's basically what, you know, if it's dissolved in water, that's going to be ions in solution. So set C and set D were the ones that they wanted you to see for number 2. They wanted you to notice that those are the ones that involve ions in solution, okay? Match each description below to one of the reaction sets. Part of an ionic compound is removed and replaced by a new element. That one's going to be single replacement, which should be C, actually, set C, okay? Set D should be the top one. Ionic compounds dissolved in water switch partners. We haven't talked about that one yet, okay? So you might have mixed up C and D, but the one on the bottom for number 4 should be C. And then the one on the top for number 4 should be D. All right? Now, replacement. When we define replacement, what does that mean? I mean, it's kind of... Okay. You can't use the word in the definition, though. That's cheating. I know. I don't know why the online definition cheated. When you replace something, what are you doing? Yeah, it's hard to say it without the word replace, isn't it? Okay? Okay, maybe trading places or something like that. You're basically, if you're replacing, you're taking the place of, right? Which is almost still cheating, but you're taking the place of. So that's what's happening. One of the metals is taking the place of another metal in that compound, okay? We already talked about what's labeled as what. Decomposition. Okay. 10 and 11, just go ahead and cross them off. We're not going to talk about that. That's a little bit too much for us, I think, especially given the time that we have. It wouldn't be too much for you guys if we had more time. We just don't have enough time to cover it. All right, so now let's look down here at number 13 and see if we can figure out which ones of these on this list are single replacement reactions. Number, the 4th one down? Yeah. Are we in agreement there? Oh, no, I put that. Okay, what's replacing what in that compound, if that's a, or in that reaction, if that's a single replacement? Okay, does everybody see that? The copper, the copper is with the nitrate at the beginning, right? The zinc replaces it, and so now you end up with zinc nitrate on the other side. So that is a single replacement, okay? That's the 4th one down. You guys see any other ones on that list that look like a single replacement?
No. Oh, yeah.
You think the 6th one? That kind of looks like a single replacement to me, right? You've got potassium by itself here. It's a little bit different because this is H2O, right? But it looks like, excuse me, the potassium is kicking out one of the hydrogens here, or really a couple of the hydrogens here because it forms H2, right? So the potassium replaces the hydrogen in this compound and becomes KOH. You could write water as HOH, right? Same thing, H2O, HOH. So if that was the case, then you could think about the potassium coming in and maybe replacing this hydrogen. So that hydrogen gets kicked out, finds another hydrogen to pair with, and then the potassium goes with the hydroxide. Okay, so that one is also a single replacement. Okay, so those are the only ones on that list that are single replacement. This one we already answered. That was a synthesis. Okay, number 15. Student writes the following incorrect chemical equation for a single replacement. Now, I talked to several of you about this already, so you already know this. But what's wrong with what's wrong with this right here? Well, actually, I think it is balanced, isn't it?
You replace the metal with a non-metal.
Okay, yeah. So remember, a metal replaces a metal. A non-metal replaces a non-metal. Okay, so look what's happening here. You've got lithium with bromine, and then you've got fluorine. Okay, what's fluorine?
Non-metal.
It's a non-metal. Good, we're getting this. So fluorine's a non-metal. What does it have to replace? A non-metal, right? Okay. So what they had it do is they had the fluorine replace the lithium, and now the lithium's by itself over here, and you've got fluorine and bromine together. But that's two non-metals. Yes.
I still have trouble. How do you tell when something, what was placed for?
Okay. So a fluorine is a non-metal, right? It's going to replace the bromine, which is the other non-metal. Okay? It's not going to replace the lithium. So that's what's wrong with the way that they wrote it. So what it should be, well, what should it be? Let's talk about, actually, what's A asking? What element will fluorine replace? Okay, so the element the fluorine's going to replace is the bromine, right? Because that's the non-metal. What's wrong with the student's prediction? They replaced lithium instead. Okay? Should have been the bromine that got replaced. It's the lithium that got replaced instead. So that's what they did wrong on that one.
I'll take care of
Oh, okay.
Okay.
All right. You mean as far as emailing her? Okay. Thanks. Yeah. Oh, wait. What's that? There's a lot of weird side conversations that just happened on the video, so, you know, you can come up with a fun story of what just happened. All right, so predict the products and write the correct balanced equation for the single replacement between lithium bromide and fluorine. So we've got LiBr. The first part stays the same, right? Plus F2. Well, what's really going to happen here? Okay. So, well, let's just get it, yeah, and we'll balance it in a second. So the fluorine's going to replace the bromine, right? So now you've got LiF. Now, wait a second. How do we know it's LiF? Why is it not Li2F, LiF2? Well, okay. So, but how do we figure out the subscripts when we're trying to figure out something on the product side? You crisscross, because this is ionic, right? This is a metal and a non-metal. So what charge does lithium have? 1 plus. Fluorine has a 1 minus, okay? Crisscross, that's just a 1-to-1, so it's LiF. It has nothing to do with the fact that it was just a subscript of 1 over here, okay? So then LiF, what got kicked out here? Bromine got kicked out. So bromine's all by itself, right? No, bromine's diatomic. It can never be by itself, so it's going to find another bromine to hang out with, okay? So this story isn't all bad, right? Yes, the bromine gets replaced, but he finds himself or something. I don't know. Anyway, then we have to balance this equation, right? So how would we balance it? 2 in front of the, which one? Which side? Left side, okay. That'll balance the bromines, right? And then a 2 in front of the LiF over here. Okay, that looks a little bit better. That makes sense? You guys kind of got the hang of the single replacement? I don't think it's all that bad, necessarily. And just remember, that's a cheaters thing, right? What was the analogy you guys used for that one? Brad and Jen and Angelina, right? So that's a good one you could use for single replacement, right? So you've got, I don't know, the lithium is Brad, right? And the bromine is Jen.
Jennifer Aniston?
Yeah. And then the fluorine is Angelina, okay? So Angelina replaces Jen, right? So then you end up with...
I like that.
Yeah. Well, you know, there's a lot of controversy there. But anyway, that's what's happening with the double replacement, okay? So if that helps you remember what replaces what, again, remember, you can kind of think of the positive ions as being guys and the negative ions as being girls in the single replacement, and it kind of works. Okay, that way you don't accidentally replace the wrong one. Of course, the trick there is still knowing which ones are going to form positive ions and which ones are going to be negative. But we know that now, don't we? Yes, please? What elements on the periodic table will form positive ions? Oh. This is going to be a rough week. Maybe I'm asking it a weird way. You have three choices: metals, nonmetals, or metalloids. Which ones form positive ions?
Metalloid.
Metals. Okay, so you knew that. You just didn't know what I was looking for. Well, some of you knew it. The ones that form negative ions would be the nonmetals. Okay, the ones on the right side of the periodic table. Okay. Are there any other... single replacements? Okay, here we go. So predict the products on some of these. Do you see any single replacements in this list? Are you saying C as in the Spanish C, like yes, or are you saying number C?
Number C.
Number C.
Letter C.
Okay, I'm going to have to respectfully disagree with you on that one.
Respectful.
That one we're going to get to in a minute, but that's not a single replacement. C is not.
All right, F.
Okay, I'll agree with F, right? You guys see F? What do we have on F? We've got zinc by itself, right? And then we have a hydrogen chloride compound here, okay? That looks to me like a single guy and a couple, and there's some trouble about to start here, right? Okay? Maybe. So what we need to do is check your activity series before we predict the products here, okay? You need to check your activity series and see if zinc is strong enough to replace hydrogen. And I hope hydrogen is on that list. I think, okay, good. Is it strong enough to replace hydrogen?
Yes.
Okay, it's higher on the chart than hydrogen, so it can replace the hydrogen.
Is it always going to replace the first one?
Well, positive replaces positive, remember? Okay? So the chlorine's negative, so the zinc won't replace the chlorine. Okay? All right, so then what's our compound going to be on the right side? Our compound. Well, don't worry about the coefficient yet. We'll balance it at the end. But ZnL. Ooh, yeah, let's not do that. You're splitting the chlorine into its subatomic particles or something. We just did a nuclear reaction. So zinc with the chlorine, right? Zinc goes with the chlorine. It doesn't replace the chlorine. It goes with it, right? Okay. So how do I write that compound? ZnCl. ZnCl. I'm hearing ZnCl and ZnCl2. How do I know? Okay. It's not because it's diatomic. All right? You only put a 2 with it if the chlorine would be by itself otherwise. It's in a compound here, so it doesn't have to be a 2. Right? It's in a compound over here, and it's not a 2. So, how do we know the subscripts? Okay, there you go. This is an ionic compound, right? And zinc is a 2 plus, chlorine's a 1 minus, so when you crisscross, you end up with ZnCl2. Plus, what's left over? H. Hydrogen's diatomic, so it's got to be H2. All right? Why I put the chlorine with the zinc? Okay, so the zinc is by itself, right? It's either going to kick out the hydrogen, or it's going to kick out the chlorine.
Oh, and it kicks out a positive.
Right, right.
Okay.
Yep. It's diatomic. Hydrogen is diatomic, so it has to be H2. Okay? Again, now notice, the subscripts do not match from the left side to the right side, do they? Right? You've got a 1 on the chlorine over here, you've got a 2 over here, you've got a 1 on the hydrogen over here, and a 2 over here. So the subscripts don't have to match from one side to the next. All right? You're paying attention to other things, like crisscrossing your charges and diatomics and stuff like that to figure out your subscripts. Okay, so now we have to balance this. They kind of started it for us. Actually, did they finish it for us? Yeah, that's all you have to do is put that 2 right there. So they were nice enough to put that there for you. Okay, that's single replacement. Now we're going to move on to double replacement. Actually, let me pause this for a second. We'll just take a breath here. Okay. So the only set left down here is set D, right? So D has got to be the double replacement reactions. So remember, we've got kind of analogies for each of our sets so far. Set A is what? It's kind of like a love story, right? Okay, the synthesis, the two of them come together. Set B, that's decomposition, that's a breakup, right? Okay. Set C, that's homewrecker, cheaters, whatever you want to call it, okay? That's single replacement. This is where it gets a little weird, okay? So set D, this is our double replacement, right? So, yeah, let's keep this PG. Yeah, there you go, wife swap. You guys ever seen that show on TV? Okay, wife swap. So they're just switching, they're basically switching partners here. That's what's happening for double replacement, okay? So, and you can kind of see this as you look at the reactions, because if you look at this side, the silver's with the nitrate, and then the sodium's with the chlorine. And then it just switches, right? The silver goes with the chlorine, and the sodium goes with the nitrate. Now, again, this is where you need to pay attention to what's positive, what's negative. This will help you not get confused. Silver's a metal, right? Metals have positive charges. Nitrate, NO3, that's a 1 minus. You just have to look on your periodic table or your polyatomic ion chart for that one, okay? Sodium is a
Metal.
So it has a positive charge. Chlorine is a non-metal, so it has a negative charge. See how that works? Don't put the positive with the positive. Remember, like charges repel. They're not going to go around each other. Okay? So the silver has to go with the other negatively charged elements. Okay? So AgCl, NaNO3. Okay? So just pay attention to what's the metal, what's the non-metal, what's positive, what's negative. That's how you swap them. Okay? I think you guys are you're gonna think these are pretty easy. I think. Yeah, it's really not that bad. No. Positive and negative have to be together. It's just the other positive and the other negative, right? If you put the positives together, they're gonna repel each other. They don't want to be around each other because they both have the same charge. Yes, and the positive always comes first when you're writing the formula. So, yeah, it's good to say that. So you can kind of look at these. They're all basically the same, okay? I don't know that there's anything tricky on this list that we even need to talk about necessarily. The one thing on the second one that's maybe a little bit tricky, if you look at this hydrogen right here, okay, we're going to call that our positive ion, H and HNO3, okay? And that's going to combine with the OH minus over here. Well, when you put an H with an OH minus, what do you get? You get 2 H's and an O, right? HOH, well, what did I just say that was? That's water, okay? So it still makes sense. It just looks a little different because you're writing it as water instead of as HOH. But it's the same thing is happening, okay?
So on the test, will you give us like that's double replacement or?
You're going to have to figure that out too. You're going to have to look at, so it's basically, the test is going to be, at least the end of the test is going to be very similar to, wow, this is a long worksheet, similar to this, okay, where you are given the reactants and then you have to predict what's going to happen, okay? And I'm not telling you that this is synthesis or decomposition or whatever it is. Okay, well, let's look at the list here for a second. So the first one, we have one element and one element, right? So, I mean, think about our scenarios. What is that? Okay, yeah, that's synthesis, right? Because we've got, this is our love story, right? Aluminum and nitrogen find each other, okay? Dinitrogen oxide, well, that's just one thing on the reactant side. So what does that have to be? That has to break apart. That's the only thing it can do, right? This one right here, we've got two compounds, right? SrCl2, AgNO3. So that's going to be, that's wife swap or double replacement, right?
Oh, I see why. We have to figure it out.
Okay. Chromium 3 nitrate and zinc chloride. Those are both compounds as well, so that's double replacement. Okay. Na plus Cl2 synthesis. And then we already talked about the last one today. That's a single replacement, right? So you see how you can kind of start telling them apart once you see enough of these? It's really not, I don't think it's going to be all that bad. You guys will be fine. We just need lots of practice. That's what you need with these. It's just, yeah, we're going to have a lot of practice on Wednesday. Okay, so back to, let's see, where's the next question that involves double replacement? Okay, well, we kind of already talked about ionic compounds dissolved in water switch partners. That's double replacement, right? There are not as many questions about double replacement. Might be. Let me get there. Okay, number 16. Student writes the following incorrect chemical equation for a double replacement reaction between iron 3 bromide and sodium hydroxide. All right, so it's incorrect. So let's check their reactant side. Okay, iron 3 bromide. Did they write the formula for iron 3 bromide correctly?
Well, wait. Yep.
Looks okay to me, right? Iron has a 3 plus charge, bromine's a 1 minus, so when you crisscross those, it's FeBr3. Well, it doesn't matter. It's in the middle, so you can't figure it out based on that. Yeah, you use the Roman numeral. Okay, so FeBr3, that's good. Sodium hydroxide, is that one good? Sodium's a 1 plus. What's hydroxide? That's OH minus, right? That's on your polyatomic ion chart. So 1 plus, 1 minus. Everything looks good on the reactant side. So, okay, another thing that they could have done here is maybe they swapped incorrectly, right? Maybe put the positive with the positive, negative with the negative. Did they do that? No, it doesn't look like it. What are the two positives on the left side? Fe and Na, right? So the two negatives are the bromine and the hydroxide. Well, no, they got a positive with a negative, didn't they? So that's okay. So what did they do wrong here? Do you do that on purpose? Do you just literally say the last thing we just talked about for the last 3 minutes, but say it wrong?
Yeah.
Okay. I just didn't know if that was on purpose or if it was on accident. Because if it's on accident, it's an amazing coincidence that it happens every single time. So what's really the problem here? Okay, so we did something wrong with our subscripts, right? Okay. Now why, let's just try and get into this person's head. Why did they make the subscripts what they made them? Yeah, they just said, oh, there's a 3 over here, so there must be a 3 over here, right? Wrong. Okay, so you can't do it that way, right? So the only thing they messed up was their subscripts. So let's see if we can get these formulas right. Chemical formulas of the products, you can just say something like wrong subscripts. So then writing the correct equation, we'd have FeBr3 plus NaOH yields. Is everybody okay with that? FeOH3. Because the iron's a 3 plus charge, the OH is a 1 minus, so then you're going to end up with that. Now make sure you put the OH in parentheses, right? Because you have to show that the entire OH, there are 3 of those. Okay? Remember, you always do that with your polyatomic ions when you're crisscrossing your charges. Plus, in ABR, 1-to-1 ratio. 1 plus, 1 minus. Okay, that looks a lot better. Now, by the way, they labeled this as a solid up here. You don't need to worry about that. there's something called a solubility chart that I actually did give you on the back of that activity series, but we're not going to worry about that. We don't have time to worry about it. Okay? But basically, certain ions, when they combine with one another, they form a solid and they just sink to the bottom. You guys remember that when I mixed those two clear liquids together and they turned yellow, and that yellow solid sunk to the bottom? That was a double replacement reaction where you mix the two things together and two of those ions formed a solid and they just sunk down to the bottom. Okay? So that's what's happening here, but you don't need to worry about predicting that. You just need to swap partners. Okay? Yes, now we have to balance this, right? This is not balanced. So this one, the double replacements usually are not that bad to balance. They always look bad, but they're usually not. So what can we do here? Okay, so you can start, with whichever one. We got to put a 3 here, right? And then put a 3 here. Didn't leave myself a lot of room, and that's it. Yes, ma'am. When you put parentheses around the OH, say that again. No. That's just for OH. You could write, that's technically correct, Fe1OH3, but we don't usually write the ones. Yeah. If the whole thing was in parentheses and there was a 3 on the outside of it, then it would apply to everything. But the 3 only applies to the stuff that's inside the parentheses. If you put the 3 in the parentheses, then it's just for the hydrogen. Right? If you do this, that 3 is just for the hydrogen, not for the oxygen, so it's got to be on the outside. Right. It is just like distribution. Yep. Okay, so that one is, did we already talk about this one? The diphosphorus pentoxide plus water? No, that's going to be a, oh yeah, I'm sorry, yeah, that's going to be a synthesis. Did we talk about that? Okay, well, at this point, I'm not too worried about it. You do have it? Okay, so we probably talked about it then, because that's, I'm not sure that anybody got quite that far on the first day, did they?
I did.
Did you? Okay, good. All right, so let's see the ones that we have down here that are double replacement. Let's do a little practice with those. We said that C and D were going to be double replacement, right? When we were identifying these a minute ago. So what would the formulas be on the product side? Okay, so the SR has to go with the NO3, right? Put it to where?
Well, it's going to be R and O3 close to
Okay.
Yeah. And then
Everybody okay with that? Plus AgCl? Wait, there's a 2 over here. AgCl2? No, this subscript has nothing to do with that subscript, right? Now, how do we know? Silver's in the middle. How do we know what charge that has? It's one of the ones you just had to memorize, right? Silver you just had to memorize. It's a 1 plus. So 1 plus with a 1 minus, it's a 1-to-1 ratio, and we're good. And we're done, right? No, we're not done yet. We have to balance it. 2 in front of the AgCl. And if they had not done this for us already, we would need to put a 2 in front of the AgNO3, right? But they already put 1 there. Okay, and then the last one here, chromium. Now let's go ahead and write the formulas down below it. So chromium 3 nitrate. That is Cr, chromium Cr. Cr3. See, everyone always wants to do this. The 3 is not the subscript for the chromium, it's the charge, right? So chromium's a 3 plus. Nitrate is a 1 minus. So when you crisscross, it goes with the NO3, right? CrNO3. I don't know why it's being that sloppy, but. And then zinc chloride. ZnCl2. Zinc has a 2 plus charge, right? So ZnCl2. I'm not going to have room. All right, so then on the product side, we just need to do our swap here. We're going to end up with ZR, say, CR, okay. CrCl3, okay. CrCl3 plus ZnNO3. NO3 is the 1 minus. Okay. ZnNO3 2. Sorry. You guys see what I did there, though? Okay, so the chromium, let's just label positives and negatives again. I'm talking so fast I can't even talk. So chromium is a plus, nitrate's a minus, right? Zinc is a plus, chlorine's a minus. So when we swap these, the chromium needs to go with the chlorine, okay, and then the zinc needs to go with the nitrate. So, and this is going to take you a little bit longer than it takes me probably to figure out what the subscript should be. But once you know the chromium and the chlorine are going together, just figure out the charge on both of those. Chromium's a 3 plus, chlorine's a 1 minus, so you just crisscross. And that's going to give you the CrCl3. Everybody okay with that? And then the zinc is a plus, the NO3 is a minus, so then you, again, zinc's a 2 plus, because we just know that one. And NO3 is a 1 minus, so when you crisscross those, you end up with ZnNO3 too. Yeah, you got to have your polyatomic ion chart out for these. Okay, otherwise you're going to struggle. Okay, so we're done, right? No, we got to balance it, don't we? This one's a little bit trickier. More trickier? I don't know. It's difficult, but not really. So where might we start on this one? Any thoughts? Chlorine has a 2 on this side and a 3 on that side, and then the same thing with the nitrate. It has a 3 on one side and a 2 on the other side. So we're probably going to end up having to put 3s and 2s in front of both of those. Does that make sense? Because we've got to get it to an even number. So I'm just going to put a 2 in front of both of my ones with 3 subscripts and then see what happens. So now I've got 6 of the nitrates, right? Does everybody see that? So then what do I need to do to balance my nitrates? And put a 3 in front of the ZnNO3, right? And then what do I need to do to balance my chlorines? Well, and now I have to balance my zincs as well, right? Yeah, so put a 3 right there. And that should take care of things. Now, again, I'm doing that very fast just because we've done several of these. It's going to take you probably a little bit longer than that. On this one especially, you might want to make your tallies underneath and just count it out, okay? All right, so that's double replacement, single and double replacement. I don't think those are going to give you too much trouble. I'm going to give you a worksheet for double replacement as well. This one does not have the answers on the back. I will post the answers on Moodle so that you can look at them, okay? But why don't you spend the rest of the time kind of working your way through these. And towards the very end, I'll give you like 5 or so minutes on this, I guess. And then I'm going to, yeah, single and double replacement quiz tomorrow. I'll hand back your synthesis decomp quiz towards the end of class, okay?